Okay, here's problems 3 and 4 of the review. In number 3, they give us a data table with the distance traveled and the amount of fuel in the tank after you drive that distance. And the first thing they do is, on the scatter diagram below, plot the remaining points. They give us 4 points, and actually what they did was they graphed 0, 55, that's that one, 220, 43, that's that one, and they did 276, 30, that's that one. So they want us to plot these 3 points, and so those are, here's 500, 24, this is 30, right? So 24 is about here, about the same as 25, so there's that point. 680, 10, 680 is about here, right? 10's here, so that's that point. 850, 6, 850 is right there. 6 is about there, so there's that. So those are those 3 points. So we've plotted the other 3 points that they asked for. The mean distance traveled is 421, so x bar is 421, and the mean amount of fuel in the tank is 28 liters, y bar. So whenever you plot a best fit line, the point that the best fit line is going to go through is not necessarily any of the points, data points. The point that the best fit line is going to go through is the point which is the mean of all the data. And the mean of all the data they give you here, it's 421, 28. And they already graphed that. It's here. It's 421, 28, and this is the mean point right there. So they said the point is plotted on the scatter diagram. You just need to figure out which one it is. It's that one. And then you sketch the line of best fit. And on a test, you always want to do this with a ruler. They always want you to use a ruler whenever you can. So pretend I'm using a ruler here. And the line would be about like that. Okay, that's not straight because I didn't use a ruler, but so it's going through the mean point, which is there. So that was sketch the line of best fit. Make sure the line of best fit goes through the mean point, which you calculate or they give you. Use your line of best fit to estimate the amount of fuel left in the tank. So if I was going to use this one, this is after a car travels 350 kilometers, and then use the line of best fit to estimate the amount of fuel left in the tank. So 350 would be here, right? And it would cross the line about here. And so this corresponds to, it looks about like here, a little bit less than 35. So I would say that's about 34 maybe, 33 or 34. So I'd say 34, and that's liters, right? So use a line of best fit to estimate the amount of fuel left in the tank, 34 liters about, okay? All right, now on to number 4. Okay, number 4, the number of bottles of water sold at a railway station on each day is given as the following. So each one of these is 1 day, and the top row is the temperature on that day, and the bottom row is the number of bottles sold. Of course, the number of bottles sold is greater when the temperature is greater. So first we're going to write down the mean temperature and the standard deviation of the temperatures. Okay, well the calculator is going to do that for us, and since we're going to be doing other things like finding R, we should just put all the data into the stat edit. So we'll turn on the calculator. Okay, and then we go to stat, edit, and I put all these already in, let's see, I put them in L3, L4, so we can see 21, 150, 20.7, 144, 20, 126, 19, 125, 18, 98. So I put all these in here already, save time. So you're going to do that, put them into stat edit. And then once you do that, we want to find the mean and the standard deviation of the temperatures. And the temperatures are in L3, and the number of bottles sold is in L4. We can find the mean of both columns at the same time by doing stat calc 2var stats. So 2var stats, we'll say is L3 is the X list, and L4 is the Y list. You change that by doing second and then like L3, second L4. You could change those numbers if they're not set to L3, L4. Frequency list we want to leave blank, and then we go to calculate. Okay, and so we're looking for X bar, which would be the average temperature. It's 19.15 according to the calculator, so we'll put 19.2. We'll just give 3 significant figures. In the IB exam, we want 3 significant figures. Standard deviation of temperature, we want sigma x, so that would be 1.45. Okay. And then we want the correlation coefficient for both for the variables n and t. So we can see that with stat, calc, linreg. So when we do linreg, it also tells us the R value, and we put L3 and L4 just like we did before. And it gives you the R value as 0.942. Okay, so that is a positive, strong correlation. So the equation of the line of regression for n on t is n equals dt minus 100. And you can see that the formula that the linear regression gives you is pretty much the same format. So we say y equals 11.5x minus 100. So you can see that the minus 100 matches up, which means you're headed in the right direction. Instead of y, they put n, and instead of x, they put t, but the rest of it's kind of the same, right? So 11.5, you can see, is the d value. So they say write down the value of d. D is 11.5. And estimate how many bottles of water will be sold when the temperature is 19.6. Well, they're asking for n, which is the number of bottles of water. D is 11.5. Temperature is 19.6, so we can fill that in, minus 100. So we can do that on our calculator. We'll go to the regular screen of the calculator, 11.5, whoops. 11.5 times 19.6 minus 100 is 125.4. So since they asked the number of bottles of water and we're estimating, we say it's going to be 125. We don't say 125.4. On a day when the temperature was 36 degrees, Peter calculates that 314 would be sold. Give one reason why his answer might be unreliable. Well, you might think, okay, well maybe he calculated it wrong, but that's not what they're saying. I'm going to retype this thing here. And instead of 11.5 times 9.6, we're going to do 36. So it's instead of 19.6, we're going to put 36. Instead of 6, we'll put 0 here. And I messed up. I put that little 4 at the beginning here. And we're going to have to get rid of that. Okay. Now I think we're okay. Oops. Didn't like that either. Okay, let's type this in again. 11.5 times. Now we're going to do 11.5 times 36 minus 100. And we're going to see that he actually got the right answer, which was 314. So Peter calculated 314 bottles as an estimate, and that's what we get when we use our formula. So why would that answer be unreliable? Not because he didn't use the equation properly. The thing is, it's like the first problem we did. Look at the range of temperatures that we sampled up until now. The lowest temperature is like 17, and the highest temperature is, let's see, is it 20.7? 21? 21 is the highest, right? So we have a cluster of points, and they range from 17 to 21. And the temperature that we're looking at here is 36. So 36 is like totally out of this cluster of points. And so what they want you to say here is that since 36 is so far out of this range, that this prediction isn't really valid, because this prediction has good data points between 17 and 21 degrees, but it doesn't have anything higher than 21, doesn't have anything lower than 17. So out of this range, you can't really say that the relationship is going to be a line anymore. So that's kind of what you want to say. That one reason why his answer might be reliable is that the data points we have range from 17 to 21. 36 degrees is much higher than 21 degrees. So it's difficult to predict n for t equals 36 degrees. It's way out of our range. So that's what they want to. That's what they want to know.